interface, so she can start writing.
This is for the layout.
Yeah, this is for the layout.
Okay. Yeah, perfect.
Yeah, so this
So you
they don't
can,
have to use because Magic you don't have PDKs for XFAB, right? So this one actually there are PDKs, so you'll get up to date PDKs for XFAB, so which is I think perfect because you can use HSpice models in the ngSpice, and then for layout you can use K layout. But she has to do a bunch of work, custom work on her own, to basically get it up and running. So. So
okay.
yeah, yesterday I was just checking the K layout and looks like they have a full-fledged editor now, and it's
It's
all
called
free.
K layout. Huh? K
Yeah,
layout.
K layout. Yeah, it's a German. It's a free open source um, environment, but what they do is I think they take a couple of it, and people write a lot of Ruby and Python script, and they kind of make their own tools, but the base one is basically free. You can download, and it's available for all platforms, all the Ubuntu's, all the CentOS, Windows. And I think best is we do it for Ubuntu for this one, because we've been doing that for the ngSpice and Su2 and CPP Sim. So that way you'll have one environment for it.
Perfect. Perfect. So this supports the XFAB node of our choice also.
Yeah, the XT01, exactly. So I was thinking of doing Vesperator. You remember this is another tool I told you they make PDK for, but this one is not free. The free one you can actually view, but you cannot generate, I think, GDS2 or something like that, the Vesperator one.
Okay.
The K layout they always used to make, but people used to use it just for viewing or making bonding diagrams. But
Okay.
turns out that that has an editor now, and it has a nice kind of a this thing. What do you call it? Interface, like a Python and Ruby interface. So all the DRC, LVS, and if you want to write any tools based on K layout, you can write in. And the open source community is pretty big in this. That's what I was seeing.
Very
So
nice.
yeah, people have already written a bunch of stuff uh, on the Python and Ruby. So I think that
Very
might
good.
be because Divya is kind of good with scripting and all that. So maybe that'll
So
be a good.
she'll be happy to know. She may be not in this call, but we can inform her and we
Yeah,
can.
yeah. I'm
I'm
I'm going
here.
to find a. Oh, looks like. Oh, yeah, Divya is on the call. Okay, good.
Oh,
Yeah,
verification
yeah.
also, Divya, you want to learn? Huh?
Don't
Yeah,
actually.
no problem. You can. Yeah, but anyway, your tasks are also being clearly, Saroj will.
Yeah, I was about to send email. I didn't realize Divya you're in the call. Yeah, so there is a
Yeah.
tool called K
So
layout.
Divya is trying hard to engage herself, Saroj. So now, if you give a task, she'll be happy
Yeah,
to
yeah.
do.
I'll send an email with the
Thank you.
details. So
Yeah,
that'll.
thank you,
Okay.
thank you.
Looks like. Yeah, I think almost everyone has joined. I think lab people are outside now. So, Poonam, you're recording it, right? Or should I? I think you have to make me host.
She's
Yeah, I'm
recording it.
recording.
She's,
Yeah, recording.
yeah,
Okay, good.
good.
All right. I think you can start now.
Yeah, yeah,
Oh,
sure.
okay, sir. I will start. Uh, so today's agenda is to understand the DV flow and uh, how the tests are running and what are the commands we use to run the test in DV. So first of all, I would like to show you the directory structure first. Avijit, can you go on back? Yeah. So here in the Pulpino folder, we have a SW folder, TB folder. So in the TB folder, we have our test bench files. Can you go once, Vijit?
So, sorry to interrupt, Yash.
Yeah,
Actually,
yeah.
before you go into the DV, what we are also hoping is that if you could give us a little bit overview of going from the config file to generating the RTL plus the firmware plus the DV environment and which tool is involved with what. I don't think that's is 100% clear to us as well. So I think
Like
that'll also help if you can.
you want to know like how to set up this environment.
Like how did you generate the RTL for the Pulpino? If you can show that process as well. I mean, you don't have to show live, but at least if you can,
Yeah,
there's a config file, for example, and they have a bunch of tools to generate the RTL. where you can choose the zero risky or risky, and then the Mac, and a couple of spy, I think is also available in that. So
Yeah,
if
Saroj,
you can show
actually
that
we
as
have
well, and
a
plus all.
document for all those things. It's called a risk v notes. Can you open once
Yeah,
that
can you
document?
just,
Go to Pulp
I think this
platform.
was shared, but
So in that, all the steps are mentioned, guess, for like how to install
no,
and
no, right. But if you can just give like a 5 minutes overview, like for example, I'll ask you maybe one straightforward question, is that how is it like from the config file, where we actually config the RISC-V processor, how is it splitting into the different environments? Like for example, there has to be one just the RISC-V core, right? And there is another one, the test bench, where it's a wrapper around the test core. And then the test bench which you're using for the DV, I know they have a cross compiler to write your C firmware, which gets compiled into some binary ASM, which gets loaded. Now, how does that get loaded? How do I access that? Like, can I write the machine language straight onto the DV environment once I write it, or do I have to cross compile all the time? If I do so, how do I not go through the whole process? That's something which will be nice to know, because I don't think that's absolutely clear to us right now. Like where is the booting from? I mean, is it like an internal RAM inside the DV setup, or how is it? I mean, do you have a block diagram you can just show us, like how this whole test flow is running?
yeah.
I think
Abhijit, can
that'll
you?
help follow what you're doing, because
There is
otherwise.
one PPT. Can you open that? Design Pulpino design verification status. Design verification status. November 2019. November 2019. This one. Yeah, first one. Go down. Yeah, correct. Go one slide up. So this is the some like
Okay,
not
yeah,
it's
no,
a general like block diagram which we had.
no, this is good. Actually, I mean, you can develop on this one. So um, now, okay. Um, so
So in this we have like a test bench, C test, and in the C test we are loading our stimuli to our instruction RAM and boot ROM, and then from that instruction RAM core is reading that data and then processing it and giving it to the UART or I2C or SPI interfaces. And then in the TV we have one SV. In SV we have UART module and SPI and I2C module, and we are getting whatever data the Pulpino is transmitting from there, and we are collecting it and showing it on our console.
so the C test you write to evaluate the RISC-V is embedded in the test bench, or is that all separate from, like, so the C test code is within the SV environment? Is that like an
No,
interface, C interface, or how is it?
no, it's separate from SV environment. It's
Okay.
not, yeah, it's not in
Because
the SV.
so the blue box you have shown test bench, what environment is that in?
Yeah, actually, just for representation, the test bench is containing only Pulpino top RTL file and
Okay.
other interfaces file.
Yes, the C code also is your top TB. From that only your C object file you are reading now. whatever you are running in the testing.
Yeah.
So the top level is a system Verilog file, right?
Yeah, in the top we are instantiating our Pulpino top RTL.
No, not only RTL, but even the C test case, test like hello world, where you're writing the C and compiling. You're using a tool chain to compile, but once you compile, that thing is linked along with the rest of the hardware, which is RTL, and simulated using the top, right? In your top.
Yeah, in the top we are simulating.
So the top is which file? .sv.
Yeah, top is .sv file.
What
Now,
I understand, Saroj, is the top is system Verilog. There is
yeah.
a way to link the object file of the C program. I think when he shows the, unfortunately, the document just recently only Narsaya and me have reviewed and told them to add that additional detail as another
Mhm.
diagram. Poonam, those things are important to close. Poonam. It won't take really long. It's 1 or 2 hours. It can be very dirty diagram. Yes, whatever you know, you can draw it on paper. You don't need to even make PowerPoint.
Right.
Draw
Yeah.
it on paper. Just take a picture and send it to Abjit and Poonam.
Okay. So,
But you know what you don't know anyway. You won't know, right? So we want to know what you know. Don't worry about what you don't know.
Okay.
Yeah.
okay. So the top one is this top.sv, which has obviously the pulp core, which is instantiated. That also is probably a .sv file, which is synthesizable RTL, but it's probably .sv. And then what else do you have in that? You have the C test, which have been like cross compiled into a Verilog test bench, or it's actually a C test which has some interface. I mean, is there a way to do a C interface from the .sv?
No,
No.
it's actually a C test, and from the C test we are directly writing into the registers of the Pulpino code. Like
No,
if
but
we
No,
that
want,
no.
interface is already done now. Yes, you may not be realizing. Yeah, Saraj, there's a C interface the system Verilog offers,
Okay.
that VPI or whatever. So Verilog programming interface or something. PLI it used to be for simple Verilog
Right.
programming language. So it is already interface. He may
I
not be
see.
realizing. Yeah.
I see. Now, if I want to write a different C code to compile it, I mean, to run it on the RISC-V core, I just write the C core, right? And everything else
Correct.
in the test bench just
Just
remains
write
the
the
same.
C code and everything else is the same process. The
Same,
make
same.
file or some file is there which you
Right.
run it and it will prepare the rest of the things.
Okay, cool. And
Yeah.
I guess you're not going to cover how you generated the RTL plus the test bench, or are you going to cover that as well?
They're taking it from the Git, the entire first cut verification environment where the RTL is already available.
Oh, I
So,
see, I see. So this is just the Debian thing you're talking about. Okay,
so the Git is as it is taken, the RTL side.
okay.
So there is no changes done in the RTL yet. That will be required for our FPGA work also.
Right. I mean, for the FPGA, they can just take the RTL because both the RTLs are
Mm,
just synthesizable codes, right? I mean, is the RTL
but
different
there,
for the FPGA one?
the RTL, this is a verification environment, right? So not everything may be synthesizable also. There could be models. It's a chip level verification environment. So there could be some analog blocks which are modeled. So they have to see
Right.
if there are any models, how do they change it to port it onto FPGA.
Not the RISC part. You mean something else, like up
So this is a
beyond
whole
the RISC?
chip. Huh? There's a Pulpino, right? There's a whole Pulpino in it, including the analog pads and everything, IO pads and all stuff.
Oh, is it? I thought this is just the RTL, right?
No,
Is
no,
it?
no. This is the
No?
whole Pulpino environment. Yeah, for chip level environment. Yeah, if I'm not wrong.
Really? Okay. Because they don't have that information till they get to basically place and route and all that stuff, right? I mean, this is, I'm guessing they just generated the RTL for the
No, for
core
the
only.
clocking and some ADC, if anything is there. Normally
Right,
in function verification at the chip level, we have all the models. So
right.
here also I expect it to have some models. Maybe just the IO buffers may not be there. Um, So we have to check the Poonam note downs, and we have to see what are the blocks which are there in the hierarchy. If it is only pure RTL, yeah, then it can be as well be also put on FPGA.
Right. I mean, that's what we are trying to do parallelly. I think Punyadeep is trying to take just that RTL and do it. They're
But
not
I
there
think
yet.
that Bhuvalan and him, I think, have not
Right.
got much ahead. I thought they're stuck on this, what to take and put it on FPGA. There is a, we'll not go there. In this
Right.
call, we'll stick to this. So the idea is to know the verification environment and also understand the hierarchy of the Verilog files we have, system Verilog
Sure.
files,
Sure.
and able to do some small cuts and take it into FPGA, or even for a verification point of view also. Tomorrow, if you give a analog block, we should be able to
Right.
replace that model.
Right. We can write a Verilog model for the analog block and just replace.
Correct,
Yeah.
correct.
Correct. Yeah. Yeah.
And do the same test. Yeah, yes,
Right.
correct.
Yeah. No, absolutely. Yeah, and I think eventually that's what we'll do with the top microcontroller. We'll have a model for the power management, for the SAR ADC, and so on, and do a verification. But I
Correct.
was assuming that this part of the verification is just the RISC core. But you're saying they actually have the
Oh,
pads
this
and
is definitely peripherals. There are, apart from the core, the SPI, all these peripherals are there. Memory
right.
also is there. PLL, I'm not sure. Yeah.
So how is the memory model? That's like just a RTL code and you choose the size for it, or how is that
No,
model?
no, there must be a memory functional behavioral model. So
Behavioral, like
Rishmita,
a C, yeah.
no, not C, Verilog behavioral model. It should be
Behavioral,
there.
okay.
Yeah. So Rishmita, on these analog things, no, you please take initiative, because Rishmita just previously in other projects, she was doing this job only. She was
Hmm.
taking the analog Verilog models, and she was building the system Verilog environment to test them.
I see. Okay.
Yes,
Yeah,
sir.
yeah.
Yes, sir.
So look for those, Rishmita. Maybe
Okay,
you
sir.
will have to model them also, because these models may not be available also. Saroj sir will give you the specification and you may have to model also.
Okay, sir.
Yeah, once we, start getting to the top level of the analog, we'll start creating those models.
Yeah.
In fact, some of the simple ones we'll just create the Verilog and give it to you. Some of the other ones maybe we'll
Mhm.
ask you to model. Yeah.
Correct, correct.
Yeah. Okay. Sorry. Go ahead, Yash. I think.
Okay. So, yeah, Avjit, can you go back to the terminal? So in this TV directory, we have our, you can see like tv.sv, which is our top module, which we are talking about. Can you open once, Avjit? So here, once go up, yeah, where that Pulpino top is instantiated. So go down. Yeah, here you can so see that our Pulpino top is instantiated here, and the all the peripherals like SPI master, I2C are connected with our SV modules, which will collect the data which whatever received from the Pulpino. Uh, like example, this UART, whatever UART TX pin will send, then it will be received in this UART RX, and this UART RX is going to another module which is in SV only, and there we are collecting the data and printing it on the console. Then go to now go to the terminal. Yeah. Then to run any test, we will go to SW folder, and then in that we will have a build folder there. If you want to run any test, then first we need to compile the RTL, and then we will run our test. So to compile the RTL, we will have to do make v compile. It will compile all the RTL files and test bench. What happened? Yeah. Now after compiling, if you want to run that test, then we'll do make then the test name. Like if you want to run hello world like test, then we will give make hello world, give hello world dot vsim. So now it will run in the model sim. Yeah, yeah, run all. Yeah. It will take some time to give the output.
So yes, looks like this is the, while it's getting you the output, I just a quick question. This is the SW apps is the place, I guess, where you do all your verification, right? All the codes you want to run to check. Is that where you write
Yes,
all your codes? And they're C codes basically?
yes. There
Okay,
only we will write our codes. So
okay,
here you will be getting output like see hello world. It is get printed through UART.
okay. Is there a good document on all the interfaces we have, like all the instruction, data cache, how to access them? Or how do you refer to it? Just from the Pulpino document datasheet, or do you have another document where you have those information? Let's say I want to write a small model and I want to do a spy, write to spy, read from, let's say I have a simple model where it's modeling a sensor, and I want to read it in spy and put it in a data cache, and I want to look at it. Is you just look at the data sheet for Pulpino, or where do you look for all those interfaces? Like when I start to write the app, what's the best document to look for?
Yeah. If we want to add like some additional test or something,
Yeah,
it is there in that this we notes, like how to add new test. Uh, the steps are mentioned there.
right. I mean, that is one thing, but I also want to know, like, how do I write tests to debug something? Like, let's say, for example, like as I said, I'm writing a spy, and I write a spy where I load some data from a sensor, and I have a sensor model in the Verilog.
So the Saroj, the
Yeah.
Pulpino data sheet, ideally, typically in STM32, the STM32 data sheet should have the memory map and the
That's a
boot.
Pulpino data sheet, right?
Yeah, Pulpino
Yeah.
data sheet should also have, but it may not have. So this is typically required for the chip level verification.
Okay.
The current tests are only they have written the block level test. So using SPI, sending data in and out like that.
Uh-huh.
So with master outside, UART also.
Right.
That is why we are encouraging our embedded people, which is Poonam, Sharad, and Sandeep. They will also join the verification activity.
Mm-hmm.
They will have to understand the memory architecture and the peripherals for the Pulpino, and then write these test cases in C. It's all C programming, so
Right,
there's
right,
no very lot knowledge required.
right.
So yeah.
Yeah, I guess once the test bench is created, you write all your codes, I mean, all your test benches in C, because you're just
Hmm.
writing, basically you're writing
Correct.
firmware
Correct.
now to
Yeah.
evaluate.
So
Okay.
eventually, the similar information is also required in a programmer's manual. Once the chip is to be programmed by the firmware,
Mm-hmm.
similar information also required. So there should be some programmer's manual. Maybe the programmer's manual may be available in a richer sense. Maybe for Pulpino or even better things, examples would be some other chips like Sci-Fi chip or the Green Waves Gap chip. They will have better documentation. So Poonam, you have to refer to those to understand the abstraction, just like they are doing an FPGA. Bhubalan and you people are supposed to look at the Sci-Fi Freedom to see how it's put on RT, what part of the SOC is available and what is removed or what is like that. So same thing we have to do here. For a data sheet level Verilog verification, people won't publish those documents. But for programmers manual, they'll be easily available. So for our information, both are same. Okay, which registers to configure, what is a memory address map, which peripherals are mapped where, things like that.
Right. And if you want to do like some deep debugging, do you do it through like JTAG, or you actually probe some signals straight into the Verilog, which seems probably
Yeah,
harder, right?
which is probing the signal. In this case, it's all signal level
Signal level.
plotting.
But do you use like the JTAG also in the DV environment to debug some stuff, or
They have to verify JTAG, but I don't think they use JTAG. They
okay,
will have to
No,
eventually
it is
verify
not
the
used.
functionality of JTAG.
okay. Maybe on the FPGA environment we can use the JTAG, but
Yeah, for the FPGA environment, we can use the JTAG.
okay.
Okay. Yeah. Then go to the terminal, Vijay. So go to the SW folder. So in this, yeah, go back. Yes. Here in the apps folder, we are having all our test. If we Imperio test, we have in the Imperio test we have the test of I2C SPI, all the peripheral test which were there, like for test I2C, test SPI, test UART, and for other tests like risk V test are also there, sequential test also there. So all the tests which we will have to write in this directory only, and then from here we can run the other tests. That's all. That's all. If anybody else wants to add anything else, can add.
Okay. And what OS do you use? What do you prefer? Like, is this Ubuntu one?
Linux, yeah,
Is it
Linux is,
Ubuntu, or do you have
yeah,
CentOS?
Ubuntu. It's
Ubuntu.
Ubuntu.
Okay.
Ubuntu is preferred.
All right. And for the whole DV environment, you don't need any GUI, right? Because I just set up a AWS. I've asked this our students to use that to set up this whole environment. You don't have
We,
anything. Oh, the V model sim. I
yeah,
guess that's
models
the only
in
one.
the student version, it should work. There's no issue.
Okay. So I guess I have to set up a X server or something there. Um, Now the model sim is only. I mean, you can run it command line as well, right? And
Yes, we
okay,
can run command line also.
okay. Just
Like,
that if you want to track any signals or anything like that, then that's when you want to use the
yeah,
GUI.
open GUI mode, yes.
Okay. Yeah, so they can at least start using in command line mode. How much disk space do you think you need for the entire thing to generate and do DV? Basically, I created an instance with 40 GB disk space. Is that good enough, or do you think I need to
Yeah,
add?
for
Okay,
40 GB, I guess it will be enough.
okay,
Yeah.
all right. Okay, so I think the RISC-V. So Satabdi and Prachita, you have the RISC-V notes, the document which Yas is showing that you have right now with you, right?
Yes, sir.
Yes, sir.
Okay. Do you guys have any questions yet from that notes, or you still kind of exploring?
So kind of exploring from that note, it is pretty
Because
clear
I guess
to what
actually Satabdi and Prachita, they're mostly now doing the pre-DV part where they're trying to generate actually the RTL core. And actually I was thinking maybe that's something we can also learn. But looks like this was only the DV part of it. But do you have any questions, Satabdi and Prachita, for the Sevilla team?
No, sir, it's pretty clear now what we have
Yes,
to
sir.
do. We just got
Okay,
got
so
an
I
idea.
think right. So I think I think you're pretty close to, or you're almost able to generate the RTL core from the config file. And now that they have shown you the DV environment, I think you can just start running some of the test cases and see if you can run it. And then after that, we can start thinking about building the microcontroller model on top of it. Okay.
Yes, sir.
All right. Thanks, Poonam and Yash. Thanks a lot for this. I'm sure we'll bother you as we go along. it's, it's pretty.
Yeah, thank you, sir.
Thank you, Suruj.
Okay, bye bye.
All right. Bye, Srikant. Bye, guys.
Bye bye. Ciao.
Yeah, bye.
Thank you.
Oh, just before I leave, Poonam, if you can just share the video once it's up, that'll be good. Thank you.
Yeah, sure, sir.
Yeah. Thank you. Bye.
Yeah, thank you.
Can I leave?
Yeah, yeah.